What's poppin', dogs? Mr. Allen here, solving some exponential equations in this video without the use of a calculator. No calc on these bad boys. So what's my strategy? Generally speaking, I'm going to try to get like bases and use my one-to-one property of exponents. So first one here, I've got 16, I've got 8. What can they both be written as with the same base? Well, 4 squared is 16, but I don't have anything for 4 with 8. What about 2? 2 to the third works for 8. 2 to the fourth works for 16. So let's rewrite that right now. And I always put this in parentheses. We have 2 to the fourth. And then we have x minus 2. The exponent stays. And then I have 2 to the third. And I have x plus 1. Awesome. So I've got like bases, but I got a little cleaning up to do before I use my one-to-one property. I'm going to multiply my exponents now, right? It's power to a power. So 4 times x, we'll have 2 to the 4x. And then 4 times negative 2 is minus 8 equals, and then we have 2 to the third to the x plus 1, so 3 times x, so 2 to the 3x. 3 times 1 is plus 3. Now I have like bases, my exponents have to be equal, right? That's how I'm going to solve this thing. It's the one-to-one property of exponents, like bases, exponents got to be equal. So I'll just disregard essentially my bases here, and we have a nice simple Algebra 1 equation to solve. Isn't that just wonderful? So I'm going to subtract 3x, I get x, add 8, I get 3 plus 8 is 11. Boom. There's my answer. And if I were to plug this into my calculator, boom, we'd have 11 minus 9, or sorry, 11 minus 2 is 9, 16 to the 9th, and I'd have 8 to the 10th, 8 to the 12th rather, 11 plus 1, I would get the same answer on each side. Okay, so you could check it with your calculator if you want, but on a quiz or test, these are going to be non-calc problems. So be ready to rock and roll without that calculator. One-to-one property of exponents comes in clutch. Over here, oh boy, I got a fraction. I got another fraction. We have fractions on fractions, man. Stacks on stacks, racks on racks. What do we do? Well, let's just ignore the 1 over 27 for now. Just 27. Think about 27. Think about 9. Could I write those with the same base? 3. 3 to the third is 27. 3 to the second is 9. Well, how do I get 1 over 27? Negative exponents give me reciprocals. So we're going to write this as 3 to the negative third to the 2x equals 3 squared to the 1/2 x plus 5. So before you were like, oh no, there's a fraction in the exponent. Now, power to a power, we're just multiplying. 2 times 1/2, poof, that's gone. Not a bad thing. So we got 3 to the negative 3 times 2x is negative 6x equals. Then we have to distribute. Think about it like almost like you're distributing out of the other parentheses there. So 2 times 1/2 is just 1. So yeah, 3 to the x, and then 2 times 5 is plus 10. All right, let's make sure we didn't make any mistakes there because I kind of like double checked some things. 3 to the negative 6x, 3 to the x plus, boom. Okay, we're good. So negative 6x equals x plus 10. I guess we'll just subtract x to get negative 7x equals positive 10. Divide by negative 7, we get x equals 10 over negative 7. So negative 7, there's negative 10 sevenths, an improper fraction, and it's negative. Oh my goodness. Now, one thing you might be thinking is like, ooh, wait, can I have a negative? Can I have negative exponents? Because you're probably going to start studying logarithms as well. And with logs, we don't want our argument to be negative, but with exponents, there aren't any domain restrictions. When you think about the graph of an exponential function, all my x's exist here. It's my y's that are restricted. So I can have any x's that I want. There's, I believe there's probably still a potential for some extraneous solutions, pending the situation, what other things you have going on. But negative exponents, negative x values are okay to have. We're good to go here. All right. If you're like, what are you talking about, exponential or extraneous and logarithms? I haven't talked about that yet. You might be at the start of this chapter, okay? So don't worry about it. Anywho, if you're reviewing for a final exam and watching this, you might be like, oh yeah, logarithms, man. I got to watch out for my domain restrictions. Let's do this guy here. We got 1 over 8 to the x, and we have 2 to the x squared over 16. Oh boy. Okay. Well, 8 to 16, they can all be written as 2 to some power. So for this one here, I will actually write it over here and work my way down. So 1 over 8 could be 2 to the negative third, right? So I have 2 to the negative third to the x equals, we still have 2 to the x squared. 2 to the x squared over 16 would be 2 to the fourth. All right. Now I got like bases everywhere. This one I'm just going to write down, and we're going to come over here. Boom. I have 2 to the negative 3x equals, and then on the right-hand side, I have like bases. I'm not ready to set things equal yet, but I can subtract my exponents because it's division with like bases. Subtracting exponents is okay. It is a property, rather. So it's going to be 2 to the x squared minus 4. Now I'm ready to drop my bases, set my exponents equal to each other, and solve. So I'm going to have negative 3x equals x squared minus 4. Ooh, man, this is a quadratic. A quadratic within exponential equations. This is awesome. I got to set this equal to 0 and hopefully be able to factor and solve this thing. So how about I add 3x over? 0 equals x squared plus 3x minus 4. And now does anything multiply to negative 4 and add to 3? Absolutely it does. I'm going all over the place with some arrows here. We have, let's see here, 0 equals, and it is x plus 4, x minus 1. That sounds good. X plus 4, x minus 1. All right, multiplies to negative 4. 4 negative 1 adds to 3. A little factor in review there. So 0 equals, actually I don't need that again. We're going to set each factor equal to 0. X plus 4 equals 0. And then I would get x equals negative 4. And then x minus 1 equals 0. So I get x equals positive 1. These are my two solutions. Negative 4, positive 1. They would both work in my original there, which is dope. Two answers that make that problem happen. Alrighty, last one. 3 parts again, guys. 3 parts here, 3 parts here. A lot of them just have the 2 and you have to get the like basis. Sometimes there's multiple things. So looks like we got 2, we got 8, we got 64. All of those can be written as 2 to some power, okay? This one I don't need to change, 2 to the 3x. This guy's going to be 2 to the 3rd. We've seen that quite a bit. And you might be like, at the start here, it's kind of overwhelming. You're like, man, how do I know all these powers? How am I going to remember all this stuff? You start seeing like 2 to some power, 3 to some power. Those are your 2 main ones. 5 to some power. A lot of times you don't use 4 because 2 to some power can give you, 2 to the 2nd power will give you 4. And sometimes you might be dealing with like an 8 or a 32. That can't be written as 4 to a power. So usually it's like 2, 3, and 5 are your most common ones that are for your bases, okay? Now 64 is 2 to the 6th. Because 2 to the 4th is 16, 2 to the 5th is 32, 2 to the 6th is 64. And we can rewrite this as 2 to the negative 6th. That would give me 1 over 64. Or you can write it as 1 over 2 to the 6th and then bring it up. But I'm going to do it in one step right there. Cool? Any questions? Nope, no questions. Okay. So I got power to a power here. Let's clean this up. We'll do it a few steps at a time. 2 to the 3 times 2 is going to be 6, so 6x equals 2 to the negative 6th. Now I have like bases. I can add these 2 exponents here. I get 2 to the 3 plus 6 is 9x equals 2 to the negative 6th. And I can finally use one-to-one property of exponents to set them equal. You can't use it here because it wouldn't be 3x times 6x. Sometimes people make that mistake, so I wait until I get it to 1-to-1, hence the name, 1-to-1 base. Same bases, one-to-one property of exponents. Now I have 9x equals negative 6. Divide by 9, and I get x equals negative 6 over 9, or, oops, not, what is that? X equals negative 2/3 with a scribble. All right. Boom. There we go, you guys. That was dope. A lot of solving. So, common strategies there, using 2, 3, and possibly 5. I didn't have any of those with 5 here, but those are your common ones for your like bases that can get you to the 1-to-1. Make sure it's 1-to-1, 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 1-to-1 before you drop your bases and set each exponent equal to each other. Hopefully all that helps you guys. Hopefully you enjoyed the video. If you have any questions or want examples, you're like, hey, can you do one like this? Pop it in the comments. Otherwise, have a fantastic day. Thanks for mathing.